Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, you are watching Study with Sheraz, and in today's lecture we are going to discuss about the applications of the Slaters rule. We had a previous video about the Slaters rule in which we described the various set of rules that are used to calculate the effective value and the sigma for various electrons present in the ns, np and n-1d orbitals. And if you have not watched that video, the link of that video is given in the description. First go and watch that video, then come toward this video. So in today's lecture we are going to talk about the applications of the Slaters rule. So 7 applications are given here and that are very much important for your paper point of view. So first of all, the first application is given that in the case of some atoms filling up 4s orbitals earlier than the 3d, it is observed that the 4s orbital is filled earlier than 3d in the atoms, just like the potassium. So why it is done? When the 3d is empty, why the electrons are going towards the 4s? The reason is that the Z effective value for the 4s is greater than that of the electrons present in the 3d. That's why electrons prefer to go in the 4s than the 3d. Here the electronic configuration of the potassium is given, that 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. The electron is going in the 4s1 even when the 3d orbital is empty. So why this is happening? This is because of the higher Z effective value for electron in the 4s as compared to the 3d. Here I have mentioned two values for the different electrons. Z effective for 4s electron is 2.2 and Z effective for 3d electron is 1. You people have to calculate the value for both these electrons that I have mentioned here, and tell me in your comments that whether the values are same as given here or not. The next application is that formation of cations from transition metals. In case of transition metal, when we are going to remove the electrons from the atom, the electrons are removed from 4s before the 3d. Why it is happening? When the electrons are present in a orbital with the lower quantum number, that is 3d, why the electrons are going out or removed from the 4s, that is with a higher n value? The reason is same in this case. For 3d electron, the Z effective value is much higher as compared to that of the electrons present in the 4s. That's why it is easy to remove electrons from the 4s that are less tightly bounded as compared to the electrons present in the 3d. I have again given values of Z effective for the manganese. The atomic number is 25 and Z effective value for 4s electron is 3.6, whereas the Z effective value for 3d electron comes out to be 5.60. You people have to calculate the values of Z effective for manganese and tell me in comment section whether the values are same or not. The third application is that the size of cation is less than size of parent atom. It is a very important question. The one word explanation for this fact is that Z effective value for cation is greater than that of the parent atom, because when the electrons are knocked out from the valence shell of an atom, the hold of the nucleus becomes stronger on the remaining electrons present in the valence shell. That's why the size of the cation decreases than the size of the parent atom. So the next application is size of anion is greater than the size of parent atom. Both these questions are very much important. It's also asked that why the size of anion is greater than the size of the parent atom. The reason is again related to the Z effective value. So the reason is that Z effective value for anion is smaller than that of the parent atom. As I have explained earlier that when an electron is added in the valence shell of the atom, the hold of the nuclei on each electron present in the valence shell decreases, and that decreases causes the Z effective value to decrease, and decrease in the Z effective value causes the size of the anion to increase as compared to that of the neutral or parent atom. The next application is that variation of the atomic or ionic radii in the period. We have learned that the atomic size or the ionic size of any ion decreases from left to right. So why it is happening? It's also related to the Z effective value. When we move from left to right in a period, the valence shell remains same, but the number of protons or the number of positive charges in the nucleus goes on increasing, and this increase in the positive charges or the protons causes higher Z effective value on the valence electrons as we move from left to right. So that's why when we move from left to right, the size of atom or the size of ion goes on decreasing. The next important application is the variation of En, that's electronegativity in the group and period. We have note that the electronegativity values increase from left to right and the electronegativity values decrease from top to bottom in a group. So why it's increasing in the period from left to right? The reason is same. When we move from left to right, the size of atom decreases. The Z effective value increases, the electronegativity of the atom increases. When we talk about the top to bottom in a group, in top to bottom, the size of the atom increases because from going top to bottom, the number of shells goes on increasing in each next step. When we move from one atom to next atom down in the group, thus successive shells are being added in the atom. So the Z effective value decrease, size of the atom increases, and with the increase in the size of atom, the electronegativity decreases. So this is basically related with the Z effective value. The last application of the Slaters rule is that comparison of successive IE values, that is ionization energy. It's observed that if an atom have more than one electrons present in the valence shell, just like the you can see aluminium, that's having 3 electrons in the valence shell. So it successively loses its electrons. First it makes aluminium plus, then it makes aluminium plus 2, then it makes aluminium plus 3. So what's about the ionization values of these 3 removal of electrons? Or you can say that third ionization energy of the aluminium is greatest, then is the second ionization energy, and the least one is the first ionization energy. Why it's happening? Because I have explained here in the point number 3 that whenever an atom is converted into the cation, the Z effective value increase. And with the increase in the Z effective value, the hold of the nucleus on the valence electrons goes on increasing. When an atom loses one electron, it's converted into M plus, that's having higher Z effective value as compared to the neutral atom. So the hold of nucleus has increased on the remaining electron present in the M plus. Whenever the second electron would be removed, it would be difficult to remove the second electron as compared to the first. And same is the case with the third electron. When a neutral atom is converted into M plus 2, the hold of the nucleus has increased much on the valence electron as compared to the parent atom. So the removal of third electron would be even difficult, even more harsher as compared to that of the first electron and as compared to that of the second electron. That's why it's here written that Z effective for M plus 3 is greatest as compared to that of the Z effective for M plus 2 and M plus. So with the increase in the Z effective value, the removal of successive electron becomes more and more difficult. So these are all about the applications of the Slaters rule. If you have any difficulty in this lecture, comment your question in the comment section. We would meet in the next video. Up till Allah Hafiz.